this is a introduction to a package that I developed. First, a backstory for this demo scene. These islands have really strange gravitational properties, and they pretty much work like planets in our solar system. So they orbit around each other, and they can float in space. So what does this package offer? What it offers is some effects that can make your game a little bit cooler. For instance, it's kind of dark in this lighthouse, and I wish to bring in some sunlight. I can do that by simply opening a hole in the wall. There are some other effects I would like to show you guys before I go into the details of this package. Let's go outside. One I really like is this star cluster one. Star cluster. Not this one, sorry. This one. One I really like is this one. Kind of looks like water on the edges. You can control the direction of it. Tell it to melt starting from the top. I really like this one too. Create really cool intros for each of your stages. Let's change the direction again. Let's tell it to come from the front. And another one I really like is this one. actually provide. What it provides is 5 sets of shaders, mainly 5 sets of shaders, and I will go through each set of shaders. If you want to see the scene for yourself, I will be releasing a web player version of this scene, so you can play around with it yourself. You might need to go to the end of this video, because I will introduce the controls of this demo, like how to call the effects from the GUI menu and stuff like that at the end. So you can skip to the end and go directly to the web player, or if you want to know the specifics or the details about this package, you can keep watching. So the first set of shaders are called the the hologram shaders, and I know I misspelled it, but what's done is done. So this set of shaders, what it does is it renders a hologram version of the object, so you can see through it. It's transparent, and at the same time you can interfere the object with noise and flickering, and you can control all these properties by changing material properties in the Unity editor. Like for this one, I used a high frequency pixelated texture for its noise, and I made the noise threshold really low, so it gets affected by noise all the time. As for this one, I didn't set it so low, and I used a hexagon texture, so when it's being affected by noise, it shows this hexagon texture. And all this can be changed in the editor, like this. This is really noisy. I don't want it to be that noisy. I can change it so it's no longer noisy. I can also change the flickering frequency. Now it's not flickering. And if I wanted to, I could change this texture called the noise texture to use other patterns, like these ones. They're not using the same texture. Or I can use a smaller texture. It's the same texture, I just applied it over a bigger area, so the pixels look bigger. So that's about it for this shader. The next set of shaders are called the stream shaders. Sorry. What it does is it renders streams of characters running on the surface of objects, and you can customize it by the characters. Like for this one, I assigned the texture that contained 0 to 9 and A to F characters. So you see those characters running on the surface. And for this one, I just drew some random shapes. And for this one, I drew some other random shapes that look like nodes. And you can control, again, you can control all the properties through the material inspector. Like for this one, it's white and moving pretty fast right now. I could change it to orange, red. And tell it to move a little bit slower. You can set two kinds of speeds. The first kind of speed is the minimal speed. So the the speed of the stream is random for each stream, for each row in space. But you can set constraints on them. Like if I set 5 for minimal speed and 10 for maximum speed, the speed of the stream would be between 5 and 10. And if I wanted it to be really slow, it would be like this. And you can also change the size of each character. You can change the size of each character, the length of each stream, and the frequency of how often the characters change in the material inspector too. And you can also do some things at runtime, like for this red box, as you can see, I'm changing the stream direction. This is really easy. You don't really have to do a lot. I wrote a script component. All you have to do is attach this script a component to any empty game object, and then you can do operations on the game object's transform to create various effects. Like for this one, I'm simply rotating the transform around the y-axis, so the stream is also doing the same. And for this one, I'm scaling the scale of the transform. So as you can see, the streams and the characters are getting bigger and smaller over time. And for this one, I'm positioning that empty game object. So when it moves backwards, it brings the streams backwards with it, and when it moves forward, it makes the streams faster. And I'm using a simple script to move it along the z-axis. And I can cancel this and move it with my control. And it's as simple as just doing operations on a transform to create your own effect. The next set of shaders are called geometry scan shaders. They look like, is it loaded? Okay, they look like this. Basically what it looks like is like this blue container over here. And pretty much it draws lines moving on the surface of the object, and for faces that are not facing the viewer or the camera, those faces are alpha enhanced. So if the lines are wide enough, it would allow you to see the surface information or the bumpiness of the surfaces. Like if you look really closely, you can see this is the container we saw earlier, and there are all kinds of bumps on the surface. And but just drawing lines on the surface is a bit boring, so I implemented a noise texture into this shader, so it can create all these kinds of different effects. Like this one, I'm using a high frequency cloud texture, and this one I'm using a very high frequency pixelated texture. And I changed the interval of the lines and enhanced the interval. I lowered the intervals of the lines and enhanced the width of the lines to create this effect. And for this one and this one, I used a low frequency cloud texture and used different colors. And you can make all these different looking materials simply by playing around with numbers or textures. It's really easy. You can do it in the material inspector. like for this one, maybe I don't want it to be so big or so thick. The lines, I don't want them to be so thick. I can lower them over here. So now it's really thin. And maybe I want it to move a little slower or faster. I can make it move faster. And if I don't think it's noisy enough, I can simply just change the disturbance coefficient. Let's change it to 24 so it looks more noisy now. And again, it's really easy to create different effects with this shader. And you can also change the line intervals. Like if I think that these lines are too close together, I could change it to 12. And as you can see, the lines are further apart. So change it back to 6 maybe. Nah, I think this was better. Okay, now the next set of shaders are called the geometry scan point disturb shader. And I know what you're thinking. You're thinking that this is exactly the same as the geometry scan shaders. And in a way, yes, because it's a derivative of geometry scan shaders, but the way it disturbs the scan lines is entirely different. For the previous shaders, the geometry scan shaders, when you apply a noise texture to it, the noise disturbs the scan lines uniformly. It means it doesn't matter where on the object it is disturbed. The noise is applied on the entire object. But as the name suggests, for geometry scan point disturb shaders, you can specify a point in space and tell the shader to disturb only those parts, like this. And again, you can use different noise textures to create different patterns when it's being disturbed. For the ground, I'm using a white texture so you don't see any noise patterns. And for this one, I'm using snowflakes. Again, no pattern. This is a white texture as a noise texture. This one is a hexagon texture combined with a high frequency cloud texture, which will be in all these textures will be included in the package. So you can see these hexagons over here, and I don't remember which one. Oh yeah, this one I'm using a snowflake texture. This one, hexagon. I don't remember which noise texture I was using. Maybe a low frequency cloud texture, I think. This one is a high frequency cloud texture. And this one is a pixelated high frequency texture. And you can change all kinds of properties. And this one I'm using the node texture that I used earlier for the stream character table. If you look really carefully, you can see the characters. There are 3 ways you can the shader decides how to disturb the point of disturb. So it's the first way is, as I already told you, the noise texture. The second way is this big green dot. You can choose to enhance or lower the width of the scan lines at the point of disturb, and the closer you get to it, the lines get thicker. And the third way you can disturb it is by pushing away the scan lines around the point of disturb. You can either push away or choose to attract. And all all these three values are pretty much shader float properties. So you can just change those float values over time to create different disturb animation. And for instance, instead of pushing the scan lines outwards, you can attract them like this, or you can simply just make them bounce back and forth like this. So you can use all those three properties during runtime to create all kinds of different effects. You can customize it and do it yourself. When you look from the side, it really looks like it's distorting space. This is what I really like about this shader. Okay, let's move on to the next set of shaders, but before that I would like to introduce another I'm sorry, I forgot to introduce something. It's that those three properties, actually you can change it in the menu. Let me show you. Let's find the point of disturb. You could change this however you want. You could just write a script to change it, and this is a broadcaster. It would broadcast the point of disturb to all the shaders in the scene. So all you have to do is attach it to a game object that's representing the point of disturb, and it will tell all the shaders where the point of disturb is and apply all the properties I told you about earlier. For instance, if you want the radius to become bigger, you can turn it to 8. Actually, this is how I started to open up in the animation, how I start the animation. When the ball is small, I make the warp radius small and grow with it over time. And you can also control the disturbance, which is the coefficient that's controlling how much is the surface affected by the noise texture. For instance, it's 1 right now. I can lower it so it's less disturbed. Yeah, so now it's white. There's no cloud pattern in it anymore, as you can see. Change it back to 1, or I can even go higher, like to 10, and you'll see it become really noisy. And you can also change the warp. Let's stop disturbing. Let's change the warp radius. Not the warp radius, the warp coefficient. If it's positive, it means it's pushing away the scan lines. If it's negative, it means it's contracting. And all you have to do is get a reference to this script, and then use your script to write to it over time. Then you can create your own disturbance animations. But what I did is I used an animator to animate these properties, so I wouldn't need to write any code for it. That's even faster, and it creates more satisfying effects. So let's move on to the script I was talking about earlier. It's called the material switcher, and as the name suggests, it switches materials. But why? Why would you want to switch materials? And this is why. I'm going to show you why. At the beginning of this introduction, you saw some effects, um, and this is really common in a lot of games because sometimes you want to enable the player to see through walls or activate some special ability to let them see some information that they normally wouldn't be able to see. So you need things like this. You can switch the entire scene's materials to use other materials. But that creates the problem. For instance, for this transparent window with some stain on it, there's surface information, and also for the bricks on the lighthouse, the bumpiness, you wish to preserve that information, and you can see that information in normal mode because you assign a bump map to it, and for this one you give the texture alpha values. So pretty much it uses different shaders to render them, and so when I switch over, I can't just switch to one set of shaders. I have to switch to several. Sorry, I can't switch to one shader, one stream shader. I have to switch to multiple shaders. Like, there's a shader that enables you to assign a bump map to it, so you can see the bumpiness of the bricks are still preserved. That's because it's using that stream shader that uses bump maps. And the material switcher pretty much does this for you. It switches the ones with the bump maps to stream shaders that have bump map properties, and it does the same thing for the transparent windows. And it's really easy to rig a material switcher. For instance, I switched to node screen, right? You can see node screen right here. All you have to do is specify which shader the original material was using. For instance, this brick wall is pretty much using bump diffuse shader. It's a Unity built-in shader, and all you have to do is specify in this element that whenever you see a bump diffuse shader, a material using a bump diffuse shader, you switch it to this material, and you pretty much just create this material in the project view, and then rig the properties like this to create a theme, like the node stream theme, and then you assign it to the material switcher, and you're done. At least for these shaders, but there are some other shaders you would need to set and do the same thing. But the concept is really simple. But sometimes this still takes a lot of time. Consumes a lot of time. So you can just copy one of my configurations and just change the materials to create your own effects or own themes. So pretty much all you have to do is just choose shaders and assign materials, and you can create a different looking special effects like all these different ones. I didn't have to, after I finished the shaders, I didn't have to code anything anymore, and because these ones are using the same shaders, and all I had to do is like create different materials, and that's it. And if you still, sometimes maybe you want to do something really different, so you can't just copy my configuration, you can I developed some scripts, helper scripts. These 5 helper scripts that can help you to configure faster. So it's real. The material switcher is really easy to use, and all you have to do from script, all you have to do is get a reference to the material switcher and call a function called switch, and give the name of the view mode as a string argument to the function, and then the material switcher would switch over for you. And when you want to switch back, you just give it the string normal, and then it will switch it back for you, and it will do optimizations and all that stuff behind the scenes. The next thing I want to talk about is the melt sources. The next thing I should talk about is the melt shaders, which is the last set of shaders I was talking about. But there are 3 kind of sources. But let me show you what melt shaders does. This one. Okay, you won't be able to see it really clearly what it does from this angle. So let's go into scene view. So when you look at it this way, you'll understand that it pretty much melts parts of the scene while rendering the rest of the scene as normal. And there are 3 sources in melt, 3 different kinds of sources. This one is called a point source because it works like a point light. Anything within range would be rendered normally. Anything outside the range would be clipped or melted. And you can change the properties. You can change the properties of the melt here. Like if I wanted it to be bigger, I can make the inner radius and the outer radius bigger, like this. And again, you bind it to a transform. You bind it to a transform, and it will the origin will move with it. So that's why wherever my character moves, the rendered parts follow. That's because I attached the object to the robot. And the next melt source would be the ranged spot source. What it does is pretty much like a spotlight. Wherever it points at, the scene is rendered. Wherever it doesn't point at, the scene is not rendered. And you can also make it render a certain color at the boundaries. And as you can see, the patterns at the boundaries are different for each one, because all you have to do is assign noise textures to it, and it will show different patterns, and the colors and all other melt properties can be changed in the material inspector. So you can do this by creating your own materials. And for instance, if you wanted to create a bubbly edge, you just give the materials a bubble texture as a noise texture, and you can have bubbles on the edge instead of snowflakes. Yeah. And again, it's really easy to control the melt spot range is really easy to control. You can to the main camera right now. So all I have to do is change the transform of the main camera to make it turn. You can also change the range and all that stuff during runtime. And the last melt source would be the axis source. The axis source, let me see. Okay. It's like this. We need to get further away to see what it's doing, to see clearly what it's doing. So you might be asking, how does it decide how to melt the scene? And it decides this way. It's bound to this transform right now, and this transform is rotating. That's why the whole scene is pretty much rotating and melting. So pretty much anything behind the z-axis of this transform would be rendered, and anything in front of the local z-axis of this object would be melted away. And you can change this all during runtime too. Like, I can pull it over here, whatever, do whatever you like with it. And the next topic should be the melt original shaders. Because when you see melt shaders, you can think of it this way. If it's not melted, or it's not close to being melted, the shader behaves as the original shader. So I call the original shader, like Unity built-in shaders, I call them original shaders. And how I did that is I wrote these shaders that behaved like normal shaders when they're not melted, but when they're getting close to being melted, they move towards a color and melt away if they're really far away from the source. So I would say that for a shader, I would create a melted version of the shader to support melting for the shader. For instance, this part is using bump diffuse. So for the bump diffuse Unity built-in shader, I wrote a bump diffuse melted shader. So when you see those lines on this part of the scene, that's because I replaced this shader with the melted shader. And now you might ask, yeah, I see you. Now you might ask me, which shaders have I written the melted versions for? I think I modified. I think I created 23 Unity built-in shaders to have melt versions of shaders, so they can support melt, like bump diffuse, transparent, alpha cutoff, the ones that use the height textures, and all that. So when you use the material switches to switch over, if you only use these shaders, for the parts that aren't being melted, it should look exactly the same. But if you're not using one of these 23 shaders, you can choose one that's closest, and it might lose some information. Like for instance, if I didn't write a shader that had bump maps, that accepted bump maps, the surface information might be lost. The bumpiness of the bricks might be lost when you switch over. But I wrote 23 of those, and if your scene only uses those, then it will look exactly the same. If not, there's a default action in the material switcher. It will use a default value or a default shader, a default material for it. So it might lose some information, but as long as most of your scene is using these shaders, then it should look exactly the same. But another problem you might want to ask is, what about the sets of shaders I told about you earlier? I told you earlier. These shaders, like the geometry scan shaders, the stream shaders, and all those other shaders, I also made melted versions of them. Let me show you. This one. This is obviously a geometry scan point disturb shader, but it also has point melt properties. As you can see, only parts around the main character are shown. Let me jump off. See? And for the stream and for geometry scan point disturb, you can, as you can see, you can still disturb it even in the melted version. So pretty much any shader, any original shader, if they support certain functions, the melted versions of those shaders will support the same functions and add melted properties to them. So you can do these effects. I forgot to show you the hologram. Not this one. Oops, too fast. Come on. Oh yeah, this one. Yeah, as you can see, they're flickering. And you might ask, why can I fill the melted holes with other shaders? And that's by enabling dual mode in the material switcher. You can enable it right here. You just click on this checkbox, then you can use these two other fields called dual switch infos, dual default info, and you set it up as as I said earlier, for the switch infos. You just set the shaders and set the default material you want them to change to. But instead, for the dual switch infos, it uses those materials to fill in the hole that the melt creates. So that's what you saw at the beginning of this introduction. Now I would like to talk about the controls in this demo scene, because I'm probably gonna upload this to YouTube, and I don't really know a lot about how to process these videos, and I think the video quality is gonna be really bad after compression. So I would recommend you to go to the link below. It will link you to a web player version of this demo scene, so you can see for yourself on your own computer. I showed this demo scene to some of my friends, but they weren't able to get even half of the effects out because they didn't know where the controls were. So I'll show you here. Let's get outside. First of all, if you want to open this window, you push C, and if you want to switch to any view modes, you just click on the button, and if you want to switch back, push N. And for any stream or melted stream, or any melted version of stream shaders, you can use the stream options down here. Like, for instance, I want this stream to move in a different direction. I want it to move downwards. I want it to move along the x-axis, or I can just tell it to align it to my view. And again, this is as easy as changing the transform values of a empty game object for any stream shaders. So that means even the melted ones, like for the axis cloudy stream. Oh, sorry. See, it's locked to my view. Put it back to Z, like this. And the next part, oh yeah, make sure you scroll up and down, because the scroll view on the top, you can scroll both horizontally and vertically. Some of my friends weren't able to see all these view modes on the bottom because you just assume that it ended there, but it doesn't. And some of these effects are pretty awesome. I like them. Yeah, and the other one is the melt axis options. You can, as I told you earlier, you can tell it to start melting in different directions. Like if I want it to melt from forward to back, I could set it to Z. If I wanted it to melt from the top to bottom, I'll just set the melt axis to Y. And you can set it to rotate. Yeah, and that's the controls for the view modes. And for the geometry scan point disturb effects, for any geometry scan point disturb view mode, you can do these operations, including the melted versions of them, like this one. You can just disturb it as long as those shaders support it. The way you do this is by you left click on any surface, and it will shoot the point of disturb at it, and then after it stops, you can you don't have to wait till it stops, but anyway, you push Z to activate it, and you push Z again to close it. When the point of disturb is not activated, you can push tab to switch between the disturb animations. You can see a disturb start 01 on the upper left corner of the screen. If I push tab, it switches to the next one, which is the one that attracts those scan lines. and the bouncy one is the fourth one. And I think that's about it. I'd really like to go through all the view modes, but the video would be like too long because I made like 101 view modes in this package. So I think you should just play the web player version and see it for yourself. And I developed all this all by myself, so I think I didn't have a lot of suggestions or advices. So if you have any questions or advices for me, please tell me. I would be really grateful for your advices, because I know when you develop these things, if you don't listen to feedback, there's going to be a lot of problems. And at the current state, I think there are a lot of problems in this package. But yeah, I think that's it. Thanks for listening.